So, hey guys, so today we are going to start with something very new. Uh, we have been talking about large language models, we have been talking about deep learning and a lot of different stuff. But today I want to talk about a new model that I was also a part of as a team. So, this is Komodo 7 billion base. So, this model is a large language model that is developed through some different techniques. So, what th- we did is get and be explained through the research paper is as following. As you can see here, so if you go through some of the statistics of the model that are present in the paper, I will give the link to the paper in the description. You will see that the most of the models that exist in the market are usually better in languages such as English, French, Spanish, or you can say Hindi, because these languages are spoken by a large variety of people, a large number of people. So but when it comes to languages which are not that famous, right, or the number of users are not that much, like Indonesia or the 11 regional languages in Indonesia, there is a bottleneck in that problem, right? So Komodo 7 billion has been introduced as a model that is a family of LLMs that consist of the base model and the instruct model. So the current 7 billion instruct model actually stands out by achieving state of the art performance in various tasks and languages, outperforming the benchmark set by OpenAI GPT, the Aya 101, the Llama 2 Chat billion, 13 billion, and the Mixtral model, and the Google's latest Gemma model. So I think you guys must be knowing about a lot of models because Llama and Gemma got quite famous in the previous few days. So let's go through some of the benchmarks that I would like to show you guys. So these are the tasks that have been done. So we have discriminative tasks and then we have generative tasks. So I'll show you some of the data. Yeah. So during pre-training, we didn't do pre-training from scratch. We used the concept of continual pre-training. So we took the Llama model and from a particular checkpoint, we started the pre-training. And you can see the data sets that have been used. You guys must be aware of the paper, which is Textbooks Are All You Need by Microsoft. So that paper was fantastic. If I would show you guys, Textbooks Are All You Need, it's a very good paper. Uh, so if you see this paper actually defines the whole concept that that you only need textbooks data to actually pre-train the model in such a way that even a 1.3 billion parameter model can compete with GPT 3.5, which is like 170 billion parameter model from what I know. Cool. So similarly, you have another paper which is Textbooks Are All You Need Part 2. That paper you can also read. I will provide the link to those paper in the description. You guys can go and read, have fun. And you can see, right, we have used Indonesian textbook data, we have used regional languages corpus, and through this we got the Komodo 7 billion base. We currently support total of 11 to 12 languages that we are not including Indonesian, so 13 languages you can say, and these are all the regional languages that are of Indonesia. After that, we took this base model and we did supervised fine tuning, the known as SFT. So we did question answering, general task instruction, summarization, and we did in various domains like legal services, entertainment, media, banking, and education. And we got Komodo 7 billion instruct. I just like this logo so much. I can look at it for hours. So coming to the part, uh, the tokenizer fertility analysis. So you guys must be knowing, fertility refers to the ability of a tokenizer to actually break down the text into units that while minimizing the minimum number of tokens required, as you can see in the definition. So one thing you can conclude from here: the lower the fertility, you can say it's better, right? So the Llama 2 billion base has in Indonesia the mean fertility of 2.8, and Komodo 7 billion has 2.031. So how we did this? Adding new tokens, making sure the merging is done in a better way. Relying on a vocabulary of known words. So this is how we achieved a better fertility score for Indonesian and regional languages as compared to the base Llama 7, like this base Llama 2 billion model, right? Cool. So if you see the scores of the downstream tasks, we have actually benchmarked across a lot of models so that everyone can have a look how are we performing better. So these are the four models of OpenAI. The GPT 3.5 has three versions. GPT 4 has the main 1106 version, and you can see, right, in most of the tasks, Komodo 7 billion actually outperforms most of the model. We are outperforming Llama 2 7 billion chat, 13 billion chat. We are outperforming Gemma. We are even outperforming Mixtral. Then we have Cohere's Aya 101. If you don't know about this model, it's a multilingual model trained by Cohere. Then from AI Singapore, we have Sea Lion 7 billion instruct. So this model was made by AI Singapore specifically for Southeast Asian languages. Then we have Alibaba's Queen and the Bactrian X Llama 7 billion. So in most of the tasks, you can see it's a competition between GPT-4 and Komodo 7 billion instruct. I agree the fact that most of at some of the places GPT-4 actually outperforms Komodo 7 billion instruct, but I hope you guys understand the fact that GPT-4 is a very big model. We even don't know the parameters. I think minimum 500 billion parameters must be there, and our model is just 7 billion parameters. But even in that case, at some places we are able to outperform even GPT-4. Not all, but yeah. So if you see the average score, right, we are getting 71.1, which is slightly above, actually not slightly, but yeah, 4 to 5% above the GPT 3.5 models, and like you can't compare even the other models with our model right now. So Gemma, I would say, has performed more than I expected, 53.4, which is actually better than Llama 2 13 million parameter model, right? And for Mixtral, actually it's 60%, looks good, and yeah. So these are the performance breakdown on the sentiment analysis. So you can see in most of the part we are actually outperforming the other models. The only competitor is either Aya or it's GPT-4. GPT-4, I agree, is a very good model. Definitely, I think in the 13 billion parameters model of Komodo, we will definitely try to outperform GPT-4. Let's see how it works. So you can see this, the generative versus discriminative tasks. We have covered in all the cases, all the models that are here. On discriminative, we are getting 72.3, and in generative, we are getting around 66.6%. So we are outperforming majorly all of the models except, yeah, GPT-4. So yeah, that's the case. And you see the heat map. So this is a comparison between the Google Translate and Komodo 7 billion instruct of the languages that are the target and the source language that we are doing for the translation analysis, right? Now the whole part is, in Google Translate you don't have support for more than 4 languages, like languages like actually Balinese, Venjaris, Burgunese are not supported by Google Translate, right? So that's the reason we have left them blank. But overall also on the supported languages, our model tends to outperform Google Translate in that case, because our model has been specifically trained for Indonesian languages and the regional languages. We tend to outperform all of the existing models and systems. So not only this, I want to show you guys a very interesting insight that Gemma is actually outperforming Llama 2 7 billion fine tune. So what we did is we took the instruct data for our SFT part, and we fine tuned Llama 2 and Gemma on the same data, and we saw that Gemma is actually outperforming Llama 2 in most of the tasks. And we haven't mentioned that table here of for each task because it would make the paper very lengthy. But the whole point was, if you see here, we have specifically mentioned that Gemma 7 billion, Gemma 7 billion actually outperforms Llama 2 in most of the scene tasks. So Gemma is very very good for the scene task. For unseen task, I have some mixed reviews because Gemma was not that good, but yeah, it was definitely good in some tasks. So this is, you can see some qualitative analysis if you guys want to see. The paper will be there, and this is the perplexity score for Llama 2 7 billion base and the Komodo 7 billion base. So yeah, we are definitely getting a better perplexity score. So yeah, then the English capability regression analysis is there. So we tested even our model on the English datasets that are present. So even after one good thing was, even after we made sure that our model is very good in Indonesian, we tend to be remaining at the same level for the English part also. You see here, right? Like there's a slight decrease, I would say, but average overall we remain more or less same, right? So this is the conclusion, and so furthermore, we are working on the 13 billion part. So definitely once it's out, you guys can go and have a look. So not only this, so Komodo 7 billion base has been open source also on the Yellow AI NLP repository of Hugging Face. So you guys can go and play with it. So these are all the things. So definitely make sure you have trust remote code equals to true, because we have made our own tokenizer, added new tokens, and embedded so embedding things and everything would be a bonding part. So make sure you have this in your code. And I think we can start with this. So here is a Kaggle notebook where I have loaded the model, and we can actually test a few things like how it works and how it is performing. So let's start with this. So I have a sample text. So please ignore me if I don't do the pronunciation that good, because I don't speak Indonesian. But yeah, let's try. So the text that I have given you, it actually means Borobudur temple is. So you see, right? This is the output that we have got. So let's test. So I have Google Translate here, and from Indonesia I'm translating to English. So it's a temple located in Mangalave, Central Java. So it's correct actually. So these testing that we did are verified only. So it's you guys can also go and try if you do if you guys want to test and play with it. So let's try one more thing. Let's ask it the capital. Let's see what happens. Ibu Kutu Kota, Indonesia. Okay, fine. My pronunciation is not that good for sure. So you see here, right? If I take this, so because it's a base model, you can't expect 100% good results, but yeah, it's decent. So has been moved to Kalimantan. So this is a future news. This is a very future news. In 2024, Indonesia will be shifting its capital from Jakarta, according to news. So that's what it is citing here. It to a city in Kalimantan. So yeah, that's the thing. So looks good, cool. I think let's ask one more question. Okay. Let's say, okay, this means actually total islands that are present. Okay, so okay, let's see what does this mean. So the total number of islands in Indonesia is 17,000 islands, and that's correct. You guys can go and verify it. So yeah, 17,000 islands are there. So these are just very basic examples that I've tested, and because this is a base model, you can't expect it to perform as good as the super fine-tuned version that has not been open source yet. Let's see what happens in future, but right now you guys can go and play with the instruct version on the yellow platform, right? And so this model you can see handle Indonesian, English, and 11 regional languages. So make sure this is not an instruction tuned model. Again, the benchmarks that you see here are of the instruction tuned model. So right now, this is what is there in the open source domain for now. You guys can go and have a look of how it is working and give some feedback, how it can be improved. Any suggestion from your side would be appreciated. And you guys can also read the paper for improving your knowledge in the domain, like how we came with the idea, and why we started this project overall, the continual pre-training part, the SFT that we did. So yeah, those are some things. And yeah, thank you for watching the video. I hope you guys learned something new about LLM world today. And you guys can actually tell me in the comment that how we can actually proceed in this series of LLM thing and improve the content of the videos. So yeah, thank you and have a nice day.